Hi everyone, and thanks for joining us for an Orion Launch Abort System Attitude Control Motor Test here at Northrop Grumman's facility in Elkton, Maryland. The Launch Abort System will play a critical role in sending humans back to the moon and then off to Mars. And we're making great progress, and we can't wait to show it to you today. I'm Natalie Joseph, and I'm here with astronaut Randy Comrade Bresnik and propulsion engineer Alicia Bet Lotto. But before we get to the test will be in a couple minutes. We want to give you guys a background on Orion's Launch Abort System. So, Comrade, tell us a little bit about the Launch Abort System and why it's so important for astronaut safety.
So you got the capsule where the people are on top of a big giant rocket. So in this case, the SLS, most powerful rocket ever built by humans. And so we've got these solid rocket motors. We've got four former, space shuttle main engines out there, and it's launching us out of the thick parts of the atmosphere, escaping gravity. Well, if something happens to that rocket, we have to have a system that can get us away faster than the rocket is accelerating away from Earth. That's where the launch abort motor comes in. So the huge launch abort motor that can pull us away from the SLS rocket. And then the attitude control motors that our friends here at Northrop Grumman are making will then go ahead and allow it to move away, because the rocket's going to still keep pushing uphill. It's going to pull it away so we can get safely away. And then once we're separated, then the abort motor goes ahead and comes off. The important thing about the system on Orion is Orion's supposed to go beyond low Earth orbit. It's not going to stay and go to the space station or stay in low Earth orbit. It's going to go a long way away. Well, we need to use our propulsion and our propellant to move that mass as far and as quickly as we can to go to places like the moon and Mars. So therefore, we don't need to be hauling around a lot of extra weight. So once we get outside of Earth's atmosphere and we don't need that launch abort motor anymore, then we have a jettison motor that'll actually pull it away from Orion and nominally. And then we can get rid of that weight, so then we can just take the mass that we need to and the weight of the crew, the cargo, the vehicle, the service module, our food, our clothing, our experiments, our cameras, to be able to go to the moon and beyond.
Awesome. That sounds fun.
It should be.
All right. Well, we are still awaiting the test, so stick with us and hold right there. But the test is actually not going to be inside this building. It's just 1,000 feet away, right outside. But this building plays a critical role in the attitude control motor. So Alicia Bet, tell us about the work you guys do here at this facility.
Sure. So within this building itself, this is where we do all the final assembly for this rocket motor. This is where the rocket motor that's out on the stand today saw all of its final, where it started to look the way that it does today, where all the pieces really came together. In addition to that rocket motor, the one that's going to be launched in June was also built and final assembled right in this building, as well as the inert motor that I have right here. So this rocket motor doesn't have any live propellant in it. Its job is to be the same weight and the same general dimensions as the live rocket motor. That allows us to do several important tests with it without having to have any explosives involved.
Okay. So I have a quick question for you. There's 3 motors on the launch abort system, and this is just one of the 3. So how do those motors work together?
Sure. So if something goes wrong, the abort motor kicks in, and it takes the whole stack away from whatever is happening underneath. This is sort of the steering wheel. So it's got 8 different valves. They're going to basically choose which direction that it's going to go in to flip the capsule back down and have it pointed back towards Earth. Mm-hmm. And then there's the jettison motor that'll separate the stack from the Orion, so the Orion capsule can parachute to safety.
Awesome. Thank you. And then one more question for you, Conrad. Where is the attitude control motor and the launch abort system on the Orion? Where would it be?
So the crew is lying on their back inside the capsule, and so behind us is the rocket, so our backs are facing towards Earth, and we're looking up towards the cone shape and the upward hatch of Orion. Well, beyond that upward hatch is the whole launch abort motor stack that we have with these 3 motors all in succession. And so we sit there, and we don't have windows, so we can't see it, but we'll know when the jettison motor goes, because it'll pull off the shroud, and then our windows will be exposed. We'll be able to look outside for the first time during the space flight at that point.
Wow. That's awesome. Cool. Well, I got a chance to ask my questions, and we're going to feed some questions from all of you guys watching us on social media. So one of the questions you got is, how does Orion compare to other spacecraft? Can you tell me?
Well, we've we went away from the shuttle back in end of the shuttle program in 2011. So it's a winged vehicle that landed in the world's largest glider at 228,000 pounds. We're going back to capsules because capsules allow us to go further and go do the long duration exploration missions out beyond low Earth orbit. And they have heat shields. And they're not meant to fly back in. They're meant to come back in with the heat shield and actually parachute back into the ocean in this case. Well, we've got commercial vehicles that are being built right now, which is really exciting because we may have in the next year 2 commercial vehicles taking humans to the International Space Station. Orion 2022 should be the 3rd U.S. vehicle that's going to take humans from U.S. soil out into space. No country has ever had 3 human-rated flying vehicles at the same time. So this is absolutely amazing, exciting times in the space business. And Orion, what's different from those low Earth orbit vehicles is their heat shields only have to be able to come back at about 17,500 miles an hour. Okay. But when you get going to the moon, to be able to escape Earth's gravity, go to the moon, come around the moon, and back to Earth, we're talking a lot faster speeds. So instead of like Mach 25 is what we come back in from low Earth orbit, we'll be coming back in Mach 32 and Mach 35. And so the heat shield has to be that much more robust. It also has to be more radiation hardened because we're going outside the Orion radiation belt. Has to have a strong communication system because we're going, transmitting from 250,000 miles away instead of 250 miles above the Earth. So there's all types of systems that are aboard Orion that allow us to do that. And then that'll be the place where we have Orion will go to the Gateway and build the Gateway space station in lunar orbit here in the 2020s. So now we've got a spot to be able to do lunar exploration, sustained human presence on the moon, as well as maybe start building our Mars-class vehicles that'll take us to Mars in the 2030s.
There's a lot going on at NASA.
There's a lot going on at NASA.
And we're making big progress, and that's one of the reasons we're here today.
Absolutely.
It's so exciting. Another question that I think is kind of funny is a lot of people have been saying, is it attitude or is it altitude? And it's attitude. So what is attitude? Can you guys explain that?
So sure. So attitude is sort of the orientation of the spacecraft in 3-dimensional space. So altitude is the height, attitude is the orientation. So therefore, our motor, 8 different directions, none of those directions are sort of down towards Earth. That's what's determining. The Abort motor is giving you attitude or altitude, and this motor is giving you the attitude.
Mm-hmm, mm-hmm. And what makes this motor in particular super unique?
It is a solid rocket motor. It does have the 8 different valves, and it's a very complex system that goes into deciding how and when to open those valves and make each of them function when they're supposed to. Mm-hmm. And it's a human-rated solid rocket motor for those designs.
Yeah, that's so exciting. Are you excited to be a part of it?
I'm definitely excited.
Me too. So how do 8 valves steer the aircraft? When do you guys answer that? That's a question from our social media audience.
Sure. So they're 8. They're positioned, in one in each eighth of the section, and depending on what they need to do, they'll command which direction it needs to go, and the hot gas will come out each of those 8 valves, and that'll, pivot it in the opposite direction.
Mm-hmm. And so basically, if this is the Abort motor, the valve opens up here, it's going to push it this way, and that's no different than any of the other reaction control systems on any of the spacecraft, or even the jet packs that we wear on our spaces when we do spacewalks. Except we use compressed nitrogen instead of solid rocket motors. But all it does is open the valves, and that then pushes you in the opposite direction. And that's how you control your attitude in space when there's no gravity.
Cool. So cool. All right. We can take, I think, one more question from our social media audience. And Comrade, this one is for you. So NASA's working with commercial partners to get astronauts out of Earth orbit and into low Earth orbit, excuse me. But how does the launch abort system differ from other spacecraft?
Well, the other spacecraft that are being developed right now, they carry their launch abort system with them on their capsule the whole time. And so they take it up, even when they get in low Earth orbit, they have it with them, and it comes back downhill with them. And so what's neat about this one is, well, as soon as we don't need it anymore, we can get rid of it, and then that extra weight we were carrying, we don't need to carry when we need to fire our motors to do the trans-lunar injection burn and get to lunar velocities and escape Earth's gravity.
Cool. Awesome. Well, we're about to go to the test. Stay with us, watch it, and come back and send your questions into us. We'll be back for a quick recap.
See you soon.
We did it.
That
was
was
a successful
awesome.
test. Yes.
That's awesome.
It was so awesome.
Congratulations.
Yes, congratulations, Alicia Bet. That was amazing to watch. Now, tell us what we just saw.
Sure. So we, ran a duty cycle to show that we could open each of the valves and that the flame would come out where it needed to, when it needed to. And so that's what you saw was the rocket motor's burning the whole time. There's always flame coming out. It's just deciding which valve that it comes out of.
Mm-hmm. What were you thinking when you were watching that?
I mean, honestly, it was just like, it's working. I love it. I love watching a test. I love, that moment of fire and seeing all the work that everybody here did and seeing it come into fruition.
Amazing. Congratulations.
And then 7,000 pounds of thrust on that motor. You didn't have to get very close to roast your marshmallows on that one. That was a pretty big flame coming out of those ports.
Well, it was successful, so that's great. And what does this successful test mean for us?
Well, I mean, we've got 3 of these tests. This was the first one, right? We're going to have 2 more later this year. And with that, by the end of the year, this launch abort system is going to be fully qualified. The neat part is we've got in June 12th, we're going to have AA2. That's an abort test number 2 for Orion, where we're going to take and launch up an Orion capsule with the launch abort system on top of it. And right at the maximum dynamic pressure, the hardest part where the air's getting compressed just before we get to supersonic velocities on a launch, we're going to go ahead and fire this launch abort motor and pull Orion away from the rocket to test the whole launch abort system. And so that's going to be huge. And then these remaining tests for the qualification modules will then make the qualification complete for when we have EM2, the human-rated, Orion capsule that's supposed to launch in summer of 2022. That'll be qualified to put the people have the people inside of Orion and provided them safe access to space and an escape if they needed it. Ideally, our friends here at Northrop Grumman have done such a phenomenal job. We'll never need their system. And it'll be able to jettison, we'll be able to look out the windows of Orion and be able to see the trajectory, heading out into low Earth orbit and then onto the moon. But we know that it's there if we need it. And so we're very appreciative for the work that they're doing.
Mm-hmm. I cannot stop smiling. I'm so excited. Yeah, it's amazing. That test almost looked better than us in our blue lab coat.
Yes.
So awesome. So we have some questions from social media. And one of the questions is for you. Did all 8 valves work correctly?
So obviously, we gather a lot of data. There's a lot of instrumentation during this course of this test. We'll go back and we'll look at that and we'll make sure that all that data looks exactly the way we expected. Visually, it sure looks like they did, but we'll go back and look at all that data.
Mm-hmm. Mm-hmm. That was a cool visual for sure. Now, another one is, I guess for you, comrade, how much thrust is produced in any given direction?
I'm going to have to defer to our experts from Northrop Grumman. I'm just a stick monkey.
Yeah,
so,
sure. That 7,000 pounds that, was mentioned earlier, that is capable in one direction.
Okay.
And so if more than one valve is open, it gets dispersed and divided.
Right.
Okay.
So yeah, you can, when they're commanded, they'll sort of command the 3 valves or so in that one direction, so you'll get a little more.
Awesome.
Mm-hmm.
Awesome.
Mm-hmm. That's amazing. Cool. Well, do we have any more questions from social media? All right. Well, thank you so much for joining us today. That was so great and so awesome to see. And I just want to thank you, comrade, and you, Alicia Bet, for joining us. And thanks to Northrop Grumman for hosting us here. We can't wait to show you more of our progress with the Orion spacecraft. So keep in tune with our social media, and we'll share more of that as we go on. So thank you for joining us.
And make sure you're there June 12th when we take the whole stack and launch it off a rocket out of the Kennedy Space Center.
Yes. All right.
Bye-bye.